We're called emergence theory, right? Because we deal in emergent information, and we're claiming that emergent information acts as a force. And I want to try to go a little slower than I normally go on my presentations, and I'm going to try to get feedback from you. And these are the sections of the series of talks. A deductive approach to the Code Theoretic Axiom and principle of efficient language. It's not just philosophical choices. There are deductive ways that we can think about this. Information is a non-conserved force, the most efficient physical code possible. So the combination of the Code Theoretic Axiom with Noether's second theorem, where the principle of least action is just a special case of Noether's theorem, implies that if nature is code theoretic, she would use the most efficient code possible, or a member of the set of maximally efficient codes for simulating what she simulates, which is the physical reality that we know through physics. And then a little bit of emergence theory notations and some tighter definitions of terms. A section on the immeasurable E, which is this quantity of information that exists on a hierarchical scale. And the higher it is on the scale in the information hierarchy, the more physical it behaves. That is where you define forces as things which instruct matter how to behave. And then dipping our toes into emergence theory physics, just with some preliminary ideas that the axiom and the principle imply, and then dipping our legs into emergence theory physics with a little bit of other things. Dirichlet integers as nature's natural number system. Time does not exist, only ordered sets. The cosmological and entropic direction of time, and then the summary. So the elements of the axiom and the principle include, but are not limited to, the following. Nature is a language expressing itself. Simple. For some sufficiently large quantity of strata 1, which is quantum information, it exponentially tends toward infinite efficiency due to the definition of what codes are and do, where emergent symbolism is in a hierarchy that cannot be conserved or limited, not even in principle. Then the potential for emergent information in a finite code theoretic universe cannot be conserved due to this hierarchical symbolic principle. Only base information in the hierarchy of the strata can be conserved logically. Emergent information grows exponentially as the strata level increase. And then the universal language must be the most efficient code possible with respect to the ratio of syntactic choices to meaning. A non-local neural network code is more powerful than an otherwise equal local neural network code because non-locality allows an additional set of connections or combinatorics, the connections across space-time. So the principle of efficient language, therefore, implies nature is a non-local neural net. And then we have experimental evidence of non-locality, which also implies this if nature is code theoretic. So empire waves, which are ordered sets of 2 or more empires, encode the full information of each particle throughout space-time. For example, an empire wave frame that existed 1 million years ago on Mars fills the empire wave domain here, locally, in each small volume. every meaningfully large but microscopic volume of space-time encodes all of reality across time in the empire wave domain, similar to how a holographic plate encodes information of the whole plate in every microscopic but finite area of the plate, and has a cutoff at the atomic scale, right? So it's not a mathematical fractal, which is infinitely scalable, but a holographic fractal keeps going smaller and smaller until you get to a cutoff. And similarly, in a discretized view of space-time, this idea of all information across all of space-time being encoded in every small volume of your body would have a cutoff. So everything is connected to everything in this view. And all information is contained everywhere. The principle of efficient language follows naturally from the Code Theoretic Axiom. So the Code Theoretic Axiom is informed by experimental evidence that nature is non-local and non-deterministic. So here, a classic clockwork universe, a deterministic algorithm just playing itself out, is rejected. And so this leaves us with only two supercategories for all non-deterministic and non-local hidden variables theories. Either nature is inherently random, and that's the fundamental stuff of reality, or nature is inherently information theoretic and therefore code theoretic, where ordered use of syntactical freedom is the key. The key stuff, the element, is the syntactical action. So random systems are non-deterministic, obviously, and we know nature is non-deterministic. So it's not illogical to guess or conjecture that the fundamental stuff of nature is randomness. But also, any code expression is random. I mean, is non-deterministic, right? So if you have somebody writing out a few lines of C++ and then they are interrupted with a phone call, and then you go to their code and you use the prior expression of code to guess what the next syntactical step or symbol is going to be with C++. Well, all you can do is predict it with some probability, which is less than 100%. So one cannot use evidence of non-predictability in nature to deduce either randomness or code theory. It could be either one. Nature may be a spatiotemporal code of self-referential geometric symbolism, such as a graph-theoretic code that plays out in a spatial domain called a graph drawing possibility space. So codes have three required components and purpose, and one purpose. A finite set of two or more unique symbolic objects, ordering rules on how you can arrange those objects. And the third thing, syntactical freedom within the rules, because otherwise, of course, it would just be a deterministic algorithm if you only have 1 and 2. And then the purpose of spatiotemporal codes is to convey meaning or information, including self-referential physical symbolic information, such as a hydrogen atom. Physics expresses as geometry in a geometric space. Classically, at a microscopic scale, everything is propagating and oscillating. And then classically, at a macroscopic scale, every meaningful astrophysical mass is both rotating and propagating. So waveform is ubiquitous. Gravitationally, all volumes of space are curved. So waveform is ubiquitous. And quantum mechanically, the quantum wave function plots into 3-space in a waveform pattern. So even statistically, we see this waveform. The quantum wave function is ubiquitous. At its simplest level mathematically, what can we say about the waveform? Naively, one may consider an oscillator vector O crossed with a velocity vector V, but this is not the case physically, because it is known that photons and electrons travel in helical paths, and all large bodies traveling through space have subtle, well, all bodies larger than a single particle, we can say, traveling through space have subtle helical paths due to their non-periodic and non-unidirectional oscillations. So if you have the oscillator that's not moving like this, but it's kind of moving, right, jittering around in all three spatial directions, then as it propagates, it's going to go in something like a helical path. So pi then is always part of one of the coefficients that generate the waveform, where the directionality of the pi component is key, because when you're forming helices, you have an absolute non-relativistic chirality, of course, in the helix, which is depending upon the direction of your rotation. So it's a product of two vectors, right, where the second component of the circular vector is the direction of rotation. So there must be a direction of rotation or orbit which serves as one of the two parts of the pi-related vector coefficient. The directionally rotating system then propagates along a standard velocity vector, the second coefficient, to form either right or left helical patterns everywhere from micro to macroscopic objects. So with the electron clock preon concept in the QSN, where again preon means that fundamental particles are not modeled as dimensionless points, they're modeled as some constellation of dimensionless points. So we can express both local and cosmological time as geometry and tensor network algebra of graph drawing connections, reducing to the raw form of these two coefficients, length and angle, pi and lines, rotation and translation, right? Rotation and offset. So with graph drawing theory, codes made of geometric self-referential symbols might be the most direct and efficient way for the universe to represent the self-referential meaning of any physical system, ultimately a quantized analog of the classic waveform and probabilistically an approximation of the currently semi-classic quantum wave function of quantum mechanics, where I say semi-classic only to mean that where the probability theory of quantum mechanics still lives in an infinite set of smooth space-time coordinates, there's some probability for the particle at time 2 to be at any space-time coordinate. So quantum mechanics remains with one foot in the ancient world of smooth space-time and one foot in the modern thinking, more mathematical, digital thinking of discretization. So that infinity of coordinates will be cast out in any quantum gravity theory that seeks to quantize space and time. So to be clear, a symbol is just an object, right? And an object in set theory is defined as anything which can be thought of. That's the mathematical definition. And so an object which represents itself or something else is what a symbol is. So arbitrarily, this symbol here can represent the idea known as change, as we use it in the delta symbol, right? Or non-arbitrarily, it can serve as a self-referential symbol to represent the equidistant and connected relationship of 3 points in a flat space. So any compound symbol or string can be reduced to irreducible symbols to use as the conserved quantity, right? The conserved symbolic quantity in a measure of a code's efficiency. For example, we could take letters and claim that they are irreducible, right? Letters in English, we could claim they're the irreducible element. And then we can measure the efficiency of symbolic expression in English as simply being the minimal number of letters that are necessary to fully express some idea. But what is the most fundamental and irreducible object, right? Thing in the universe of all objects which can serve as symbols. So we can let the mathematicians argue how to break a tie, a possible tie, between two candidates, the empty set and the zero simplex, in other words, the dimensionless point. The equidistant array of 3 points in a flat space here may be most economically symbolized by 3 instances of what is arguably the simplest symbol possible, or at least the simplest symbol that is amenable for use in a symbolic language, since it's difficult, at least for me, to use empty sets themselves as self-referential symbols in some symbolic language. That is, this is symbolized by this. And to express the object described by the fully connected equidistant set of 3 points in a flat space, one can introduce what may be the second symbolist object, which is the 1 simplex, to build a compound symbol or spatially arrayed network of such symbols as the 2 simplex. So at this level, one may do away with the 0 simplexes or points altogether and use 1 simplexes as the simplest possible dimensional symbol, a symbol that represents a connection between 2 irreducible 0 simplexes. So we're starting to get into the ideas of graph theory. So the purpose of being precise in this way is in order to talk about quantifying symbolic load in some self-referential geometric code. So graph theory is the theory of connections between objects. And because points are the simplest or second simplest object, connections between points can be expressed by 1 simplexes as self-referential symbols for point connections. So certain neural network theories are graph theories played out in spaces called graph drawing spaces. Here, one can have an abstract possibility point space where coordinates can have points registered as on or off, so you can have this binary action, and where near neighbor distances between on and on points would define how such on points are connected in a given state selection of on-offs of points on the possibility space. Okay? I know this is super, super simple, but I want to make sure that as we go deeper, we've covered rigorous definitions, or I've at least defined my own definitions so that you can you can follow the deduction. So in such graph drawing formalisms, the fundamental quantity is either length, right, because it's graph drawing, now you're in a space, so you're dealing with length, or the binary on-off registration of points in a given state selection upon the possibility space, where the graph theory, the graph drawing theory itself animates out into ordered sets of such state selections. So as to the 2 axiomatic conjectures, whether it's randomness or code theory, that is your deductive choice that you have to start with any physical theory, neither of which can be, as I said, easily argued by experimental evidence yet. So which is more simple or logical, right? Is it that nature is inherently random, or is it that nature is inherently code theoretic? So interestingly, that depends on another deep question. Well, what is energy and space and time in the first place? So of course we can recognize that matter is bound energy in some sense. So let us call energy, space, and time stuff, right? And let us admit we don't know what it is. So we can still ask and wonder what it is. So what is it other than what it does, right? Because we know what energy does, but what is it? So there are countless arguments nowadays in the literature that explain in very straightforward ways why this stuff is information. In fact, If you go to the contrary view, there really are no straightforward arguments to explain how energy is not information. You only have interesting arguments on how it is information. So the standard non-information theoretic view of physical stuff today is really an axiom. That is a thing that cannot be proven. It's the starting axiom. So they just say, well, look, it just is. That's where we start. We don't want to go below that. We just say energy just is, and we don't know what it is or how it is. But scientists generally should go as deep as they can possibly go, even where it's uncomfortable, in terms of probing questions. So it is an axiom or conjecture chosen by a physicist as a stopping point in the scientific inquiry, right, in the direction of reduction. The axiom itself that the physicist presumes to be true without much evidence. So today, there are a great number of physicists presuming the information theoretic view, a growing percentage. And this is where it gets interesting with respect to the randomness versus the code theoretic question, nature is random or nature is code theoretic. So to drill into this important choice that each physicist must make, either consciously or by implication of which models he or she accepts, along with its axioms, one must unpack definitions and make choices. So what is information? What is symbolism? What is meaning? So information is meaning conveyed by symbolism. Meaning is just relationship, e.g., this is like that, right? As mentioned, a special class of meaning is that meaning conveyed by self-referential symbolism. This is like this. So here we can reduce to the special case of spatio-temporal or ordered sets of spatial geometric symbols, such as the symbol for the equidistant array of 3 points in a flat space being represented by itself. Information as a force. This is probably the deepest takeaway message from this 2 days of discussion, where information is a force. So is information a conserved force? We'll get into why it's a force later, but is it a conserved force? Well, base information is conserved. Emergent information cannot, even in principle, be conserved, and we'll drill into that argument. Base information at a naive level set in smooth space-time can be understood as quantum information. At a subquantum mechanical and quantum gravity level, it can be understood by first principles-based graph actions defined either geometrically or algebraically as this object that I'll define later, which is called an AB equals P solution, which would be represented on a tensor network where A is the algebraic analog of a hypervector associated with a Lie algebraic stack strata n, right? Something in the Lie algebraic stack of some Lie algebra where this hypervector is an algebraic operator from somewhere in the algebraic stack. N minus strata m, where n and m map to a lattice and one of its sublattices. So in other words, say the E8 Lie algebra is your algebra that you're dealing with, and then you take some subalgebra of E8 where you recover an algebraic analog of your hypervector components. So then B is the algebraic analog of Lie lattice M. So when you hear me say ABP solutions, which I'm going to now use kind of as a term around here at QGR, we mean an algebraic interaction between a Lie algebra and one of its subalgebras. So P is the algebraic solution of AB, which maps to a geometric cut and project operation between some set of coordinates in lattice n and sublattice n minus m. So the non-conservation of energy, of information, the non-conservation of information goes to the very core of what we're doing here, the very core of code theoretic quantum thermodynamics. So what do you believe, what you choose to believe about this question changes everything in terms of what you might predict as a physicist for physical experiments or thought experiments. So it's worth going very slow and thinking critically along the way. How many ways can you order 16 objects? About 21 trillion ways. Far more information than the sum of the 16 objects themselves, where those objects are simple. Similarly, the set theoretic combinatoric subgroups of a given large integer are far greater than the base information necessary to describe the integer itself. So before going further with this, let me take you back to an analogy that I have used before to illustrate the hierarchy of emergent information above strata 1 base information. So we take the Bible with its 3.5 million letters, and we analogize the letters to irreducible units of quantum information or graph actions or shift vector actions on E8 or individual tetrahedron state selections in the QSN or with some set of these AB equals P solutions that I speak of. So we're going to call the 3.5 million magnitude of quantum information at strata 1 I. So that'll be a symbol that I'd like to use around here. So it'll be a serifed italic small case I. So we randomly order all the letters of the Bible. So does I become I plus or minus n, right? I is this quantum information. Does it? No. If you randomly organize 3.5 million letters that are in all the chapters and books of the Bible, you do not change the quantity of letters. The magnitude is still 3.5 million. So the answer is no. It's conserved. It does not become I plus or minus n.
So n is just any random number, right?
It's the Bible. It's 3.5 million letters. And the question is, if we randomly order the letters in the Bible, does
but that's so the I is the information.
I
the
is
Bible,
the base information.
The base information, and the n is?
N is just some value.
So
I is
any random number, right? That's my question.
Random.
Just
okay.
any number.
A permutation?
I think I should go back because
Okay.
instead of answering yours, I'm just going to re-explain it. I is a magnitude, okay? And it's a magnitude of base information in some physics system. And I'm using the analogy of the Bible where we're saying that in this Bible, we agree that we cannot reduce the symbolism of words, sentences, etc. We can't reduce it any further than the letter. Okay? This is what I'm forcing in the analogy. You might say you could break letters apart, but I'm saying let's agree that our strata 1 irreducible unit or symbol are the letters, the 26 letters of the English alphabet and some punctuation. So we have 3.5 million units of that in this object, this system, the Bible, and that is strata 1, right? And that's a magnitude, and we're saying that I has a magnitude, in this case, of this number, 3.5 million.
Okay.
Okay, so then I just say kind of an obvious question, but
Right,
so
but because it's a little bit confusing when you use the letter N, because N before means the lattice, remember?
oh yeah, I apologize.
So this
yeah.
N is just a number.
Yeah, sorry about that. Yeah. So then we randomly order, we have this magnitude I that's arranged into words, sentences, paragraphs, chapters, and so on, and has a lot of information, right? But we're only defining I as the base information, analogous to quantum information, okay? And we're saying, just because we randomly disorder the whole thing, do we change the magnitude of I? And the answer, now that you understand this, is of course no. We don't change the magnitude of the conserved symbolic information by rearranging it. Okay, Ray, we should.
That's?
It's emergent information.
Right, that's no longer base
It's no longer base what you're thinking about. That you get more information when you order them in words and phrases. That is emergent information.
That's no longer.
Ray, let me give you a simpler example. Take the word dog and call each of the. Take a byte. Let's take a byte since you're a programmer. We take a byte, right? And then we disorder the 8 bits. Is it still a byte?
Yes, but a different byte.
Then that's a bad example, so I need a different example.
Mm-hmm.
Do you understand how we can analogize letters to strata 1? Do you understand the idea of an information hierarchy? Language. We have.
Yes, but for me, when you reorder, the hierarchy is lost. The meaning is lost. So the I is lost, no?
No, because
no?
I is the base information.
The hierarchy itself can go to infinity in principle, right? So we have 1, 2, where organizations of 1 become hierarchy 2. So we're going to call that words, right? Letters, right? And so we can see here sentences or clauses, and then sentences, and so on, right? So here, if I'm defining I've defined I as letters.
With no order, because any order between the letters would be emergent information.
Well, actually,
yes.
I is.
It's just the number of basis symbols.
Right.
That's right.
The maximum number of your symbols. So
yes, the number of symbols.
So it can be ordered though, and still the I is there. So whether ordered nicely or not ordered.
But the order is not I. It's not part of I, because the
That's
order
right.
would
That's
be
right.
the word.
Exactly.
It's not a quantification of information.
The ordering, but it can still be ordered, and you can still assess the magnitude of I.
It does not contribute to I. Yeah. I is just like, for example, 26 letters, and that's it. No matter how they ordered, because the order is the emergent information, because they become words.
Yes.
Yeah. So I mean, does not matter if they ordered in whatever way, but those does not contribute to the information I. It contributed to the next level.
So can we say
That's right.
Can we say instead of the magnitude of the quantum information, because that's a bit misleading, can we say the maximum number of elementary symbols?
Yes.
Because that's
But
what it is.
Yes.
but how's that different than what I'm saying?
Well, when you say the magnitude of quantum information,
Yes.
Ray can understand that it contributes to your information when you have an order.
Yes,
It
but
increases
the analogy I'm trying to establish here is I'm saying that I'm establishing this idea where there is a strata 1 quantum information. Let's call it a spin state, okay? So if I have 5 spin states in some ordering over time and space, and then I have another 5 spin states in another higher or lower complexity structure, how many spin states do I have in each system? 5. So the spin states as quantum information, or the letters in the Bible, the quantity of those elements that in your given system does not change. So this is called strata 1, and I'll be using this word strata 1 over and over in the talk. So it's good that we go slow. So strata 1 is your conserved magnitude of base information.
So yes, the I is a number of qubits, for example, or qubits if it's a symbol. For example, a Hebraic letter, it's a Q22 its. But the letters of the Bible itself is not a good example, but because then it's no more quantum information, it's not quantum information. Each letter has a fixed value. That's why it's basic information.
I'm
yes.
calling it base information, and I'm using the word analogous. So I'm saying it's analogous to an idea of, say, spin states. It's a
state. It's just one state then. And if you change the order, you just generate another state. Not the same.
There's another way to look at it in terms of, well, this analogy here, let's say if it's in Hebrew, right? So we have actually a certain amount of symbols. But if we reduce to binary, like Ray is saying, we have a string of binary digits, right? We just have a string of them, and we look at all permutations of those. So I think Ray, what he had in mind at first was the permutation space. So let's say this permutation is mapped to this point. This permutation is mapped to this point. So what it does is it fills out this space of permutations that has vertices, and that can be modeled as something called a permutahedron. As a special case, so that's actually that's a different space than what you were talking about at first, but that also will play a role with scattering, for instance, later on. So you're looking at permutations, but that's a very large space. There's a restricted subspace of that where you look at bracketings of that information. You can bracket it, and that's where you get the associahedron. So this is a different space, but it'll be related to what you're talking about later on.
It's going to be in the realm of emergent information.
That's right.
Basic information.
Right. Yeah. That'll come later.
So we're gonna.
Just one second, please. So the last thing, when you say, because I think still this is where the confusion was. In your model, quantum information is always base information, and base information is all of it quantum. Because you said the magnitude of quantum information in strata 1.
Yes.
Does this mean that all your base information is quantum information, and those are equivalent in your model? Can you have information that's emergent and still quantum? And can you have base information that's not quantum?
Yeah, so we should try to define this, and we have options. But what I suggest for now, okay, is that we we clarify our definition of quantum base information, okay? It can be something like spin states, because quantum information, if you just say it or you find that in the literature, quantum information could also include complex topological phases with entanglement. All of that is quantum information. But I'm talking here in the analogy of the Bible, trying to relate it to an analogy in quantum mechanics as a sort of irreducible form of information. So in quantum mechanics, you can have some very primitive information, such as spin state. In coding theory, with computers, you can have irreducible state as a bit. Okay, so we're going to go over this again and again in the presentation, and I think it'll get, if it still remains blurry in any way, it'll get more clear. So, yes, Pascal. Oh, okay.
It was just the concept of atomic information with the etymology. Atomic information is something that cannot be divided, so
right.
Then it can be used to build as multiple blocks. So
thank you. That's a great example. So
yeah, but then it gets in contradiction with the physicist language, because if you say atomic, then quantum information is not atomic.
But we know what you mean. Yeah. Yes. So okay. So so clearly no. The answer, that was supposed to be fast. So the base information, when you reorder it in a random way or in another complex way, doesn't matter. Reordering does not change the magnitude of the base information, small I, in the strata. Yep, Marcelo.
But in case of self-referential symbols and code, a graph, if you rearrange randoming and make connection, you get symbols. So it's.
When we go deeper into this tomorrow, I'll be explaining.
You can get self-referential symbols that have meaning by a random process. So
yeah. So
can be.
Yep.
The meaning can change.
Yeah.
So I'm going to be showing you guys very clearly tomorrow how information in this physics that we're going to build is about order and only order, so that if you think of the action horizon shell model idea, or you think of a laser show. So we have a sphere here, right? And inside of the sphere, we have a little man with a laser pointer. And he points a laser to this coordinate on the sphere here. And then he turns it off. You take a photograph of that, 3D photograph. Then he points it somewhere else. So what is topologically, there is absolutely no difference between the one point on this two-sphere in his frame 1 or frame 2. So let him continue doing this, pointing it at different places on the sphere, and make a 24 frame per second animation that he plays for you for 3 seconds. In one case, all of these identical things, ordered in a certain pattern, can create the illusion of a quasi-particle where you see a butterfly floating like this and a little girl chasing after the butterfly. The complete illusion of simultaneous points creating coherent pattern in quasi-particle concept. And yet, at each individual frame, if you just look at it, it's nothing interesting. It's just a sphere with some point. He can then reorder the frames into pure disorder with a random number generator. And he plays the 24 frame per second animation. Now what will you see? Now you will see a light green haze, noisy, over the whole surface of the sphere. And in both cases, there were 3 times 24 different repetitions of the same object, just ordered differently. So in the same sense, the action horizon shell model, where these AB equals P operators in a tensor network generate ordered sets, you can have noise, like the Dirac sea, a concept analogous to Dirac sea, or you can have extremely coherent quasi-particle propagators moving through it. So now, those 3.5 million letters in the Bible, they organize at strata 2 into 811,000 words. So switching to the physical analog of this analogy, how do you account for the information theoretic value of 811,000 words? Or 811,000 units, I mean, of your quantum information, your 3.5 million letters rearranged in this interesting way with words. So the words, by the way, can be randomly organized. So I'm not saying that at this strata 2, it necessarily means that the words are organized into the clauses and sentences and chapters of the Bible. So how do you account for that? How do you put a magnitude of information on these words? Or do you not, right? Because you only want to do it if there's a reason to do it. So quantum information or classic microstates or graph theoretic actions, right? Doesn't matter what analogy is. The fundamental units can be many different things in many different codes. But when those units self-organize, or you organize them as complex systems of I, you can get higher strata. So this is strata 2 in the Bible example, words. So do you just ignore it? Is it physically causal and not implied by the sum of the information at strata 1? Right? Of course, it's not implied in any way by the sum at strata 1. So even though we do not know how to quantify this emergent information that results from organizing the 811, the 3.5 million fundamental elements, letters, into these 811,000 words, at least we know that the value 811,000 at strata, sorry for the typo, at strata 2, at strata, at least we know still that the 3.5 million letters is still conserved, and that's still the fundamental base information. So let us attach some unknown algebraic value, which is called E, which I'm going to be arguing becomes a force. We're going to use this symbol for E. That's called emergent information. So E is anything above the conserved base information. So E2 is just strata 2 as our value of emergent information in the form of words in the Bible. And let us say, so in other words, we're attaching some value to it, right? I haven't said much about what that value is like yet. And let us say that the sum of I and E2 and E3 to E infinity equals this symbol, capital I, a serifed I. So I use capital I for information as the sum of all information from strata 1 to strata infinity. And I'd like to use the little italic serifed I for the base information.
So wouldn't I be infinite then?
I is in principle in code theory infinite, and I'll get into arguing that because you can never find an arbitrary cutoff of your compound symbols. So little I plus E2 is greater than I when E2 is greater than 0, such that I is generally greater, capital I is generally greater than little I. Make sense? Okay. There are about 31,000 sentences in the Bible. We can assume strata 3 level emergent information is greater than strata 2 information. In other words, capital I is distinctly not Boltzmann or Shannon information, which is closely analogous to quantum information, and many people have done lots of work connecting Boltzmann and Shannon entropy to a quantum version.
So you're equaling quantum information to base information here?
Yes.
But in strata 2, it was not base information, quantum information.
No.
So this is why it's a bit...
Oh, but wait, why?
Strata
I didn't
2
say, wait.
Strata 2 is also quantum information, but it's no longer base information.
Yeah, it's emergent.
Well, as we said a few minutes ago, we have to create some clarifying definitions for the discussion, and I admitted that quantum information could include anyons, right, in a topological net. That can be, if you like, can be quantum information, but I suggest for this conversation, we discuss an idea of irreducible quantum information, such as spin states.
Yeah, but still, I mean, you have quantum information that is composed by base information plus emergent information, or just by base information?
I'm going to go back.
In this presentation, he means just base
Yeah,
information.
but in strata 2, you did say, in strata 2, if you go back one slide, you said that that's quantum information when you were talking about E, which is in fact emergent information.
Right, so quantum information is does not equal to base information. Maybe you should.
Okay, go, tell me the slide. So
I think it's the one just before. Value of 811 units of quantum information. So
right,
that's emergent.
but since then I covered this 10 minutes ago where I clarified. I said, generally, quantum information can mean things like anyons, which are clearly not base information, or all sorts of hierarchies in quantum strongly correlated quantum systems. We have all different strata of quantum information. So I had to clarify that here I'm trying to just get you through an analogy of general code theory, and don't get too caught up yet. Maybe I should have not mentioned quantum information, but I tried to apologize and define by saying in this analogy, I'm saying we would have to make the analogy work, we have to, for this discussion, talk about a quantum information which is an irreducible, simplistic base form like spin states or something.
Right. Our problem is that it is in this example, quantum information is not irreducible because it's already formed by emergent information, aka your words. That's our only problem.
Yeah, you're using quantum information to mean two things. So one means base information, the other one means the emergent information too.
It doesn't though.
Well, right here it also includes the emergent information.
Oh, I told you, I said I'm sorry for the typo. So let me apologize again and clarify. I made a typo here. This is a flat out typo. Yeah, no, and I said though, I said this should have been 3.5, but what was written is not, so I understand the confusion. No, that's a typo. This is 3.5 units of million units.
So for this presentation, quantum information equals base information.
That's right. Or you can say base information for this equals some well-defined types of quantum information, such as spin states.
I think there's probably a cleaner way to express this and get away from sets. It's easier visualized in terms of categories. So in that case, your hierarchy there starts with one category,
right,
2 category, 3 category.
Right.
So these n categories, you can take them out to infinity.
Right.
So you have your primary points, your point space, right? And you have mappings between them, these points, which are one morphisms.
Yes.
But you can have the triangle map to another triangle state, which is a 2 morphism.
Right.
You see, so you can encode this higher dimensional strata.
In our formalism, we're going to be using category and set theory, because category theory is nicely amenable to stratification ideas like this.
And graph theory as well.
Yeah, and graph theory. But we're also going to be using a notion that's more common to set theory, where you deal with order. Right? Because as we get into this idea like I described on the sphere with the laser, order is the name of the game in any theory using quasi-particles and ordering, right? So yeah, but that's true and good that category theory is perfect for ranking a set of a series. All right, so thank you, Cinziana, for keeping me honest here. All right. So I'm going to go over this again. We're attaching an algebraic value here, calling it E. That's my symbol for all strata of emergent information. And then when we have a subscript on it, it is the categoric rank of where that is in the emergent hierarchy. So in the Bible example, E2 is words. And there is no E1, because E1 would be small I. So let us say that the sum of I and E2 to infinity equals all information, the capital I. And then it follows that I plus E2 is greater than I when E2 is greater than 0, such that I is generally greater than little I. So there are 31,000 sentences in the Bible. We can assume strata 3 level of emergent information is greater than strata 2 in this hierarchy. In other words, capital I is distinctly not Boltzmann's. Our information as the sum of little I and all E is information, and yet it is not the Boltzmann-Shannon information, and it is also not any quantum irreducible information such as spin state analog of Boltzmann or Shannon's entropy. This here that I'm talking about is something altogether different. So what? So what if it's different? What's the big deal about all of this E and this capital I not being the sum of small I. What's the big deal? Why would I be physically important as long as we account for the sum of the irreducible quantum information? Because information acts as a force, where one can easily define a force, such as gravity, as something that instructs particles how to behave and self-organize. Take, for example, DNA. It has some quantity of base information, little I, but it has emergent information at several strata up the emergent hierarchy, where such information includes a particular four-letter code made of geometrically arrayed composite symbols called proteins, made themselves of simpler systems all the way down to fundamental fermions and highly organized clouds of photons mediating those relationships. And then underneath the fermions and the bosons, perhaps there is some quantum gravity theory where things are reduced even further, all the way down to maybe graph connections, right? And all of that builds up in the emergent hierarchy to this abstract four-letter code of DNA, which is a code that encodes the entire biosphere's evolution on Earth for 4 billion years, which is like a third the age of the universe. It's remarkable. And what does this code of these abstract things do? Well, this emergent spatiotemporal, self-referential geometric code contains protein folding algorithms that instruct bosons and fermions, as well as their emergent non-fundamental objects, atoms, molecules, proteins, how to self-organize. In fact, in special cases, such as DNA, the local power of this self-organizing force in a small volume of different masses and bosons floating around this special molecule, that force of influence eclipses other forces to become the dominant force that is instructing and guiding, like an orchestrator, how bosons and fermions, and under that, the graph actions, should behave. Of course, this informational force uses electromagnetism and ultimately quantum mechanics to orchestrate these self-organizing instructions to the mass energy in the system. The information high up on the strata, this four-letter code of DNA, is of course specifically not the sum of its quantum information, which is conserved. One might claim, okay, but Klee, it requires an investment of energy or quantum information to achieve the organization of this special case of DNA. Well, that's patently untrue. The term self-organization is helpful here to understand why it is untrue. That word means that the system uses its own energy to organize itself. Consider, for example, the case of a particular ratio of some species of atoms at energy x in a liquid form. Now allow the energy x to dissipate from the system such that it is at energy x minus n. Now, certain annealing patterns of dissipating energy will allow the system to self-organize into a quasi-crystalline array of masses, where extremely strong quantum correlations exist. Quantum correlations are in the emergent hierarchy of information at strata greater than 1. Now, once the system locks into this self-organized, conserved energetic form, that is itself not the most homogeneous distribution of energy possible, it will remain in this less than minimally entropic state upon cooling toward absolute zero. And yet,
this is not a clear because this kind of system need a heat bath to, I think. It's not it's not his own energy all the time.
Let's
Your experiment provide a heat bath from where it gives this possibility to maintain that organization.
No, if you take this quasi-crystal, which microscopically it's not the most homogeneous distribution at the atomic scale of the energy, and then you allow it to continue to cool. So you're saying it cools in a heat bath, right? Right? That's how it would cool, by dissipating its heat. Then you're saying that is a counterexample to the notion of self-organization, where a system self-organizes under its own energy, right? I don't think so, but you may be right. I'm willing to deeply probe this in some discussions next week. But although a heat bath can be, you may consider that a heat bath is required, but I'm not sure that it destroys the statement that I'm making, that self-organization itself does not always require the self-organization to organize into an equidistant array of masses such that the energy of the system is microscopically distributed in the most homogeneous manner possible, which is what the second law is about. Because the second law, after all, is naive. The reason it's naive is because Boltzmann didn't understand quantum mechanics. He didn't really understand gravitational theory deeply, and he discounted it anyway because he figured for steam engines, gravity was a trivial force. But we know that gravity does remarkable things in the universe with respect to self-organization. In fact, we once had a hydrogen universe with just that one simple atom, and it was specifically gravity that self-organized the universe into 81 stable elements, right? So he didn't account for the self-organizing power of attractive forces such as gravity, and he didn't account for complicated patterns of van der Waals forces that better exploit the attractive electromagnetic forces. What he did is he took the simple example of a monoatomic gas and put one temperature of the gas in one half of a closed box in a thought experiment, and another temperature of the same gas in the other side. Now, with this special case of this example, of course, the gases will act as repelling charges, the two temperatures, and eventually you will have a deep microscopic homogenization, right, of the energy distribution once you remove the barrier separating the two halves of the box. Because the second law contemplates, above all else, repulsion, repulsive charges. But when you get into, I can give you dozens of examples other than my quasi-crystal example. The quasi-crystal example required a recipe. It wouldn't have done that unless you followed one of the 300 known ratios discovered so far in quasi-crystallography, where you have to take exactly this ratio of just these, for example, 3 atoms. And it can't be the same ratio of a different set of atoms. It has to be those 3 in these ratios. And then and only then do you get the system in its dissipation in the heat bath to self-organize into this non-microscopically homogeneous distribution of energy, where they're not acting as repelling charges only. It's a dance, it's a special recipe of repulsion and attraction working together in complicated ways, unlike the naive example of charges in a closed box.
Yeah, but still, if you let the system cool down toward 0 K, that's Bose-Einstein condensate. I don't think it will maintain its original structure.
Okay, but I disagree. I think that if you allow a quasi-crystal to cool, once it's locked, so there's a principle of locking in at this special phase. When it locks at that special phase, which requires the ratios, you can continue cooling it. You can go down below liquid nitrogen and lower and lower. And in fact, instead of decomposing into a crystal, what happens is the phonon activity calms down towards 0, and you start getting extremely strong quantum correlations describable by anyons, where the system becomes a topological phase of matter because all that exists at super low energy is the quantum effects, such as entanglement and tunneling.
Yeah, I think it really requires a certain kind of cooling. Like it probably has to be like a very fast, like when it reaches certain temperature, exactly the temperature, you cool it like instantly, but not to 0 though still. Like I don't think if you cool it to 0 degree, it will maintain that, first of all. And also that kind of cooling is not like, it's assisted cooling almost, in a way.
Well, quasi-crystals exist in nature outside of laboratory synthesis. They exist in space.
But not 0 K, right?
No. I'm saying even without assisted or manipulated recipes of quenching.
Right, but it has an environment. The environment may play a role because it's not like, it's not isolated.
So what you're saying is you think that as you go to a cool enough temperature, the system will start decomposing into a crystal.
It becomes like a 1. It's like if you look at
yes, it does. Quantum mechanically and topologically it does. But the masses don't organize into an FCC lattice.
You cannot distinguish the structure anymore at that temperature. So there is no structure.
Well, what I said is that when you've calmed down the phonon oscillations and you're left only with the extremely low temperature phazon actions, where the phazon hops at very low temperature can only be explained by quantum tunneling. I had a Skype call with Dr. Tai yesterday, and he admitted for the 3rd time that at low enough temperature, his experimental evidence is clearly implying that the atoms can tunnel. Quantum mechanics allows it. We showed in our paper that we published how special reduction in spatiotemporal freedom exponentially increases the tunneling probability of the atoms. So my point is to agree with Fang that it evolves once you calm down the classic activity of the phonons. What happens is the system becomes something more magical, like quantum mechanics. It is a strange system. It's a topological phase of matter, and we have a paper showing that quasi-crystals are now known to exhibit the fractional quantum Hall effect, defining them as topological phases, where you can describe it as anyons, which are these strange global particles patterns flowing through the bulk. So it becomes a weird, exotic material, but it does not, upon lowering lower and lower, somehow then self-organize into the crystal state as repelling charges would. And that's my only point, because the second law of thermodynamics is about the maximally microscopic homogeneous distribution of energy. And so where you're using atoms, that's your cutoff. So now it becomes a sort of maximum sphere packing problem, where to maximally distribute your masses and your energy in the system, which correlates to the distribution of the heat, then you generally are going to need it to be in an FCC lattice configuration, except in certain cases where the ratios are special and then attractive forces. Because remember, it's repulsive forces that cause things to want to be evenly distributed in terms of their near neighbor distances. But when you get into attractive forces and special ratios, where you can have energy well distances that are more than 1, right? So in an FCC lattice, the near neighbor distances are 1. Okay, but when you get into complicated patterns of different forces, because you have different atoms, and if they're the right ratios, you can get into systems where it relaxes down to a system of near neighbor distances and energy wells, which is not one. You need a monoatomic set of atoms to do that. But when it's two or more atoms, there's a whole family of different non-homogeneous, distributions.
Yeah, but to what you were saying before, about the second law, it's not because Boltzmann did not know about these laws.
He didn't know about quantum mechanics.
The thing is, he chose the example of the monoatomic gas because in this picture, in the picture that he painted, every other interaction, so you need the simplest case, every other more complicated interaction will actually consume more energy from the system. So any new interaction, any force that acts upon the system, it doesn't matter that it counts as a counterpart to a different force. Overall, the kinetic energy of the system will have a contribution coming from that force. So his monoatomic gas was like the simplest example with the smallest number of interactions that he figured.
Yes, but my point is that that special case is correct. In other words, when you use that simplest case, which is a special case, then it is correct. That's exactly what will happen. But when you use different cases, then different things happen. And also when you pull in emergent information, such as anions and all sorts of other things, different things happen. When you pull in gravity, different things happen. So if you bring in attractive, my point is going to be that attractive and repulsive forces are very different in terms of exotic materials science, and you're painting special paintings with two colors of paint, attraction and repulsion. And as long as the ratios are right, then there can sometimes be special cases where you get these organizations of matter that are not crystalline, they are not like even distributions of charges. And then when you start lowering the temperature of such special systems, what happens is the classic phonon activity calms down towards zero, and what you're left with is an extremely strongly correlated quantum system where new and little understood forces come into play, like anions and all sorts of other topological quantum forces.
But overall, it will still lose more energy the more complicated it gets, and that's why
it's closed. It's a closed system, so how does it lose energy?
Yeah, but Marcelo was referring not to a closed system when you were talking about the heat bath, right?
Sorry?
When you were talking about the heat bath, you were referring to a closed system?
Can we close them or open? You need the
heat bath in order to recalibrate the energy of the system. So it's lost in that sense. You don't need to lose outside. You need like loss from the energy that you have in your system. Because there's a cycle.
Well, I'm okay with losing the energy to a heat bath. My focus, Cinziana, is on the microscopic homogeneous distribution of the energy. And all that I'm saying is that in special recipes, special cases of organizing things, what happens is these emergent symbolisms, like with DNA, come into play, and they start instructing and orchestrating the van der Waals forces and the quantum mechanical strongly correlated forces in such a way that the distribution is no longer the maximal homogeneous microscopic distribution, as would be the case in a simple case of repelling charges.
Yeah, I think we can agree. Yeah, I think we can agree with that.
Okay.
When the system cools down, it does not have to go to this homogeneous or crystal or that.
Okay.
So
a lot of discussion happened in the break, and definitely we need some cleanup on some of the mixing of my analogies. But I leave you with some simple thoughts. The universe is self-organizing in a manner where the energy distribution is increasingly non-homogeneous. And the E of the universe is increasing exponentially. And one explanation for this could be gravity, which it seems to be an attractive force, unlike repelling charges, where repelling charges seek to homogeneously distribute things, and attractive charges tend to want to cluster things. Also, the second thought is that there's not enough discussion in classic thermodynamics and modern materials science on how to exploit the power of E. And by the way, I independently realized E, but I did not discover it as an idea first. It's already in the literature where people are talking about the power of information itself in the form of the organization of the matter to then act back as though it is a force upon further evolution of the system to self-organize it. And then that new state of self-organization has this quality, that one author called F, the symbol F, and I call the symbol E, and that it acts back in a more profound way for further states of self-organizational evolution. And when you look at a system like Earth, where things like DNA encode this abstract information of hereditary propensities for violence or protein folding algorithms, you have a very special case of a biosphere that tends toward infinite complexity as it fractally branches out and new species emerge within the niches like a branching tree of previous species, such that between asteroid impacts that might reduce the quantity of species, as long as you can go without a giant catastrophic event, the branching out of the quantity of species in any epoch of our fossil record branches out fractally. And the more complex the system of some quantity of species is, the more power it has to form the environment. Our atmosphere is exactly the way it is because of microbes that existed 4 billion years ago. And humans, one single animal, have changed the chemical composition of the ocean and the atmosphere and terraformed the ancient skyline of New York into what it is today. And so there seems to be no upper limit on the power of high levels in the strata of E to loop back and guide the self-organization of a system using its own energy. No new energy, just more powerful ways to strategically use the energy. In order to do that, you have to have systems such as DNA that are capable of holding in their emergent strata very sophisticated information encoding schemes. And now humans have taken it to another level where we're using digital technology and written word and other things to encode ever more high strata of emergent information that acts back on the system. So we'll move past. So I think that the first law of thermodynamics through the lens of emergence theory and code theory is true, that the base stuff, whatever it is in your particular formalism, the irreducible stuff is conserved, but it seems that the second law, when gravity is considered, right, so there's no new energy being put into the system of the universe, and yet the self-organization and dehomogenization of the distribution of heat and mass energy is continually not just more non-homogeneous, it's specifically more complex in terms of complex systems theory. And then you take quantum mechanics, and it's well known that we barely understand today in 2017 the strata of strongly correlated quantum systems. It's one of the best frontiers of science for a new PhD to try to get involved in physics, because that's where the technologies in advanced nanocluster technology, quantum computation, higher temperature superconductors, all of this stuff is coming out of this regime of combining quantum mechanics with its strata of emergent quantum information that acts back on systems to discover new ways that were not thought about in the 1970s, for example. I mean, that were just not exploited. So the first law, I think, is a law, and that's because the base information in a code theoretic view must be conserved, and the strata 2 and above cannot be conserved. So in the code theoretic quantum thermodynamic view, which regards total information as a non-conserved force, strata 1 information I is conserved, while the sum of strata as I cannot be conserved, even in principle. Self-organization can continue arbitrarily high up the emergent hierarchy via self-organization, which means it uses its own energy. That's the definition of self-organization. And there's an entire branch of study about all forms of self-organization, from in biology, biological systems, to quantum materials. So, in fact, I talked to Dr. Tai yesterday, the inventor of the Ti-type quasicrystal, on a Skype call, and he said he's not working on Ti-type quasicrystals anymore. He's working on catalysts because of their power to self-organize systems. And generally, catalysts are almost always, well, the catalysts that he works with, and the interesting catalysts, are those catalysts which are orderly but aperiodically ordered atomic motifs. So, and then the paper that I mentioned that discusses this quantity F, which is like my emergent information, that author deals with polymers and the ability of polymers to self-organize systems as though they are a force. So,
yeah, it's the Eric Verlinde.
Yeah, Verlinde. Yeah.
Verlinde.
Yeah, Verlinde.
The idea of entropic force.
Right.
So this idea can be a generalization.
Right. He calls it an entropic force. Erwin Schrödinger recognized in DNA this idea of negative entropy. Okay, so the point is this was not what Boltzmann was thinking about. He was thinking about steam engines and repulsive charges, and in that regime, he was correct. Okay, so unfortunately, the second law of thermodynamics, as I said, ignores gravity. It ignores quantum correlations, especially strong quantum correlations. And it even ignores highly organized systems of attractive, repulsive, and van der Waals forces, which, instead dealing mostly in Boltzmann's view with the notion of repelling charges. So there's these three different cases where you can find strange, kind of anomalous results. And this one is this requires either biological evolution to figure out how to make something like DNA, which is a complicated motif that requires the right ratio of the different elements, and then it, like Tinker Toys, it uses the paints of attractive and repulsive van der Waals forces to create a stable molecule that instructs matter how to behave. Or humans can do it. So humans have invented so far 300 recipes for quasicrystals, each requiring a very precise ratio of a very specific quantity of 2 or more atoms. So it's not really a law, it's a tendency. It's a special case, and it's a very popular and common special case for simple systems like monoatomic arrays of repelling charges in an approximately closed system. So back to the instructive Bible analogy. We have these strata as letters, words, clauses, sentences, sentence clusters, paragraphs, chapters, books, volumes, etc., right? Now, there's a cutoff here at volumes, right? Because you don't get bigger than the Bible, right? The cutoff, unless you're Catholic, and then you got some extra books. But then there's a cutoff there. So the cutoff in this analogy at book volumes is, of course, not fundamental. It's just my analogy. In principle, how symbols at any strata, there's nothing to prevent symbols at any strata from self-organizing into compound symbols at a strata higher. So in principle, language, code theory, this notion, you cannot invent an arbitrary cutoff or find a logical reason why there would even be a cutoff. And therefore, emergent information tends toward infinity, can tend toward infinity. So what is this word dog? So it's just a symbol for the idea that you're holding in your mind right now of that furry animal, right? But that symbol is composed of sub-symbols that also have meaning for you, because that D has the meaning for you. Maybe it has the meaning that is something like this sound you make with your voice, duh, or it could have another meaning like a bad grade you got in school. But the rank 2 compound symbol dog has emergent meaning for you that is above and beyond the sum of the sub-symbols, DOG. So now I'm being very redundant, and I apologize, but this was what I was doing when I typed. So this is similar to the idea of how an adenine molecule in DNA is a symbol composed of sub-symbols at lower strata below the adenine molecule. So both physically and in the Bible analogy, all symbols across all symbol strata non-locally interact to create an exponentially complex hierarchy of combinatorial symbolic meaning at higher strata. For example, you can have a cluster of sentences in the Bible that give you some meaning about a character or some physical event in paragraph 1 of chapter 1. Then later, at paragraph 8 in chapter 10, there's another cluster of symbols that gives you some other emergent symbolic meaning that you combine with the earlier cluster of meaning in the story in paragraph 1 to create a new combinatoric strata of emergent symbolic meaning that is a compound symbol between that meaning there. So this is just an analogy that I want to extend. So each level of meaning between 2 or more strata anywhere in the emergent hierarchy is a new combinatoric expression of meaning and is itself a new compound symbol that expresses meaning or information of rank greater than 1, and therefore where little I is less than I in the vast combinatoric information space of the potentially infinite set of emergent strata in the hierarchy. So you may say, okay, Klee, this Bible example is getting tired. What more can we say physically about this idea? So in a complex system, physical system, there can be countless gravitational and quantum correlations and other correlations that are non-computable in a finite universe. For example, there is a quantum wave function for literally every combination of elements in the universe. But as the universe continues to click along at 10 to the 44 discrete frames per experience that we call a second, the already non-computable trans-temporal and trans-spatial combinatorics proceeds to penetrate even deeper toward infinity at a violently exponential increase of combinatorics. So information over n frames at strata 1i is conserved. However, unless one can argue why there would be a cutoff in the emergent hierarchy of self-referential symbolic physical meaning, total information as the sum of combinatorics of strata 1 to strata infinity cannot be conserved. So to finalize this point, we should ask ourselves, what is information, physically speaking, at least? Does information include the feelings and the thoughts that self-organize under the informational instruction physically encoded in the sound vibrations of an emotional song? Can that emergent information, your feelings and emotions about that experience of those vibrations in the air, can that information act back upon bosons and fermions, instructing them, orchestrating them like a force, how they should self-organize as you cry or you dance around the room? Well, indeed it does. Even though the current non-code theoretic paradigm in science today, which is still steeped in smooth space-time, which you can't really have code theory in smooth space-time because a code must be a finite set of objects or symbols. It can't be infinite. It's still, we still have a lot of thinking that's in this smooth space-time non-code theoretic paradigm, and we even have a lot of older Newtonian ways of thinking hiding in our scientific discussions. And so these ways of thinking, which are firmly rooted in the last couple hundred years, tend to trivialize this idea that ultra-high strata of information, like the experience of a song, and how then that causes you to self-organize the environment, it would trivialize that. You could hear some certain person laughing at that idea, right? Well, how about the high strata of collective scientific knowledge that's evolving through our society lately here on Earth? Is it changing things in a coherent and physically meaningful way? They call it the technosphere or the noosphere, right? It's the collective body of evolving knowledge that goes across time, because it's not just us here, it's kind of a system that goes back. Well, did it terraform the ancient skyline of New York City? Did it change the chemical composition of the oceans and the atmosphere? Is there some natural cutoff in the degree or the magnitude to which this kind of emergent information, like the technosphere and scientific knowledge in general, as it increases, this information, can it go further in self-organizing matter in and around Earth? Is there a cutoff? Is there a cutoff in the magnitude of this emergent information? And then is there a cutoff in the extent, the reach to which it can self-organize the universe? Is there a natural distance cutoff on how far this exponentially evolving set of emergent strata can just self-organize the whole universe, in principle, right? So the generation of ultra-high strata of information or meaning from a conserved quantity of base information, no pun intended, is actually only limited by the imagination. It's not limited by physics or any logical first principles. And imagination of how to create ever more complex systems of order that can act back on bosons and fermions and space-time to instruct it how to behave is therefore unlimited in principle. And that's an important cosmological concept, and it's also an important concept for materials science and building new quantum technologies. So information simply cannot be conserved. Only quantum information or some fundamental base quantum information or some similar notion of ideas like zero-point energy can be conserved. And the higher the combinatorial rank of strata on this emergent hierarchy is, the more it acts as a force and the more profound it becomes as a negentropic value defining a new code theoretic quantum thermodynamics. All right, so this section is called the most efficient physical code possible.
Just
yeah.
a synthesis of this section. It's like the Code Theoretic Axiom requires a no-equilibrium thermodynamic for a specific system.
Right.
So And non-equilibrium thermodynamics is very complicated. It's 100 years studies, like hydrodynamics is one field inside this. And there are no unifying approach because each system is complex systems is different of other complex systems. So maybe here we have an opportunity to have more unified approach to this non-equilibrium thermodynamics.
I think it starts with a quantum gravity code. In order to do it in a smooth space-time and have some rigorous way to deal with off equilibrium quantum thermodynamics, you have to cast out the infinity, and you have to have a way, to rigorously deal with things, and that's where a graph drawing code could come into place, because with a graph drawing code, right, this graph theory placed in a space, you cast out a large infinity of coordinates in both space and time where a particle can be at time too. So it changes in a very deep way quantum mechanics, and it begins to make it, at least in principle, hopeful to have something that you can drill down deeper into the math of this type of graph drawing and define information as emergent patterns of compound symbols starting from your graph symbols, where your foundational irreducible graph symbol is either a point registered as on or off in the graph space, or a connection between 2 points is registered as on and off.
Oh, I just wanted to add on to your mention of increasingly complex emergence, right? So let's say if the book analogy, right, the Bible. Let's say I wrote the Bible, for instance, right? But if I write it as a story, because in the Bible there are cross-references, later in the Bible it's referencing these old verses, and you have meaning going back. So it's not just forward propagating, you have back meaning that occurs later.
Yeah.
So as an author, I can look at it this way. If I wrote the book and already know the climax, all I've been doing is foreshadowing the whole time.
Right.
So the meaning might not be conveyed initially.
Yes.
But later in time, all the meaning comes together in the climax. And that's what makes a grand climax.
It's like a strange attractor. So I'm going to talk about this later, but I want to say it really fast right now. So Freeman Dyson gave a talk that was really cool at Harvard once. And he encouraged all young mathematicians to dive in to the world of fractal and chaos theory for one reason. He said, it's completely unlike most of the rest of mathematics, because mathematics is starting with these delicious, acceptable, almost irreducible axioms of logic that are easy to accept because they're so simple and pure sounding. You still have to choose, right? But you choose and it feels okay because it's reasonable. And then you build up, right, through to your proof from that. He said, but that's not the case with fractal and chaos theory. Fractal and chaos theory is a modern phenomenon available only with the advent of modern digital computers, which allows human mathematicians and physicists to take 100 billion floating point operations, and then at the other end, okay, to get a pattern of some form without ever being able to probe the black box of this 100 billion floating point operations. So you don't know, like normal math, a buildup where you can chase it down and follow the path. And then what they do is they analyze these patterns for which they do not have a deep understanding. And one of the fascinating things about dynamic fractals in fractal and chaos theory is the strange attractor. And a simple way to think about the strange attractor is that there is some future evolution of the system, analogous to Mike's endpoint in his novel. And Mike's endpoint in the novel from the future evolution draws, like a gravitational attractor, the story and the evolution toward itself. And that's what a strange attractor is in fractal and chaos theory. There is this future state, and it pulls, like an attractor, the evolution, acting as a strange force from the future of the evolution of the system. It's really bizarre. And Freeman Dyson said, nobody understands it. Like, we don't deeply understand it. So there's a lot of opportunity for young mathematicians to make a name for themselves by digging into this black box of what happens in these countless, floating point operations in some massive computation. So
Klee, maybe you want to summarize the part one is about the universe is not deterministic, it's not random, and it's code theoretic.
Okay, thank you.
And the second part
yeah,
is about, the information.
Okay, thank you. I'll try to summarize a couple bullet points from the first section. I'm suggesting that information begins to act as a force, and when you account for that, as well as gravity and a few other things like strong quantum correlations, it's not so clear that the premises of the second, all of the assumptions of the second law may turn out to be a bit different. Okay, that's one thing. The other thing from the first part of the talk is that there's a hierarchy that as Mike said, category theory would be a great way to deal with. It's not just this force information like the other author came up with in terms of information, emergent information. In my view, I'm connecting it to language. And in all language theory, like Ray told me that on my favorite movie of a DVD, he told me that there are about 10 different strata, each one more complex and built of the other, of compound code objects. And the simplest example is that bits become bytes, and then bytes become another object. And each object is in this hierarchical strata until at the end, my laser reader on my DVD player gives me this fantastically complex pattern, right? And that's a principle that the total sum of those strata in any kind of generalized code or language formalism, it simply cannot be, there's no cutoff. So information in the universe tends toward infinity. Does the DNA information with the 4 letters that encodes the entire biome of Earth, does it require any more or less energy or even objects than the disorganized array of atoms in DNA that you kind of randomly organize? So it doesn't. And it's super abstract, this 4-letter code. It's like it's almost in a non-geometric realm, and yet it's defined by the geometry as well over time and space of how the atoms oscillate and how they're arranged in 3 space. So that's very exciting, and it's kind of, I'm sure it's not a novel idea. I'm sure that this idea can be found somewhere in writings, but I think that it's not a frequently discussed idea, and I don't think anyone has made it as rigorous as it can be. Because after all, to make it rigorous, you have to choose a language, right? You have to choose a code before you can start making it rigorous, defining the hierarchies, dealing with it. And so now this section is going to say, all right, maybe it's logical that nature's a code. If it is a code, it would probably deal in syntactical freedom as the fundamental stuff and not some universal random number generator as your axiomatic object, right? Because those who say that randomness exists, they have absolutely no explanation for what generates the randomness. That's their starting axiom. So as you know, I have this crazy view that some of you share, which is that the most logical explanation for what chooses the syntactical freedom in the universe would follow naturally from emergent information. By the way, we talk about DNA being up high on the hierarchy. Are you the sum of your DNA? Of course not. You, as a massively complex system that has this apparent consciousness, you're not the sum of your DNA. So you've got to be way higher up the strata of emergent information compound objects than DNA, and you're conscious. So following the same logic of if you can't find a reason for a cutoff within the laws of physics or what you know about quantum mechanics, then you should more safely assume there is no cutoff. So is there a cutoff beyond you? Can a system in the universe way higher on the strata be more conscious than you, right? It'd be arrogant to say anything other than yes, probably, right? So how much more conscious, right? Can it be trans-temporally conscious? Can it be trans-spatially conscious? Quantum mechanics at least allows you to say maybe without people laughing at you, right? Maybe a trans-temporal and trans-spatial consciousness of immense magnitude is possible within the laws of physics. And whatever is possible, given enough time, eventually occurs. And so that's my best guess because I like explanations. And it's my best explanation for a kind of, like in Star Wars, there's the Force. Like some kind, I have no idea what it would be like, but some kind of universal emergent consciousness fantastically higher on the emergent hierarchy than we are can somehow act as the C plus P operators or can act as the spin network operators doing Clifford rotors or whatever, right? Cut and projection operators. It can be something like that. And it has to have language or syntactical freedom. It has to be a code. So it's the fundamental stuff. But at least there's an explanation for it. It's not an axiom that you stop at because there's a full circle of explanation. See, that's the interesting thing about our program. It appears that we may not even have an axiom in the first place, not how you normally think of axioms. Because axioms are that place in a physical or mathematical theory where we're below that, you have no explanation, like there's no explanation, you just stop there. In this view, you say that the universe self-actualizes itself in a sort of A causes B causes C causes A causes B circle of full explanation. So it's really an interesting thing if you like the philosophy of math or physics, you like those kind of deep questions. The circle ABC is logically consistent with explanations wherever you are. You could be at A, B, or C, and there's an explanation.
Yeah, it's so the most I would say close model to this would be Frank Tipler's omega point cosmology, where the complexity increases, and towards the end, all the information has gathered. He imagines it at a big crunch. So it depends on the big crunch.
Right.
But I talked to Cinziana, maybe that's not really a necessary assumption. But at that big crunch, this complexity has increased vastly. So it's all life in the universe would have just come together in some probably singular consciousness or conscious entity, some very advanced life form. And he imagined that at that point it had the choice whether to create another Big Bang or not, or re-render history. Or so
it self-creates itself. Self-organizes.
That's what he envisioned.
So in some sense, finishing the summary, I am suggesting that physics, reality as we know it, is a living code, right? It's a code that self-actualizes itself, where you can say, well, what is the consciousness within which this abstract spin, network lives in? And you can say, if a sufficiently large enough consciousness were interested, it could hold within its consciousness the abstract information of the spin network. And then you could say, but where did the sufficiently large consciousness come from? And you could say, oh, well, I thought I told you. That comes from the self-organization in the emergent code of the spin network itself. It's a circle of causality, and it's fully logically consistent. And so what I poetically would put out is that it is as though the universe is like a living neural network that is abstract, which self-actualized itself and continues to self-actualize itself.
It's like a self-regulated organism, like
Yeah.
a human body, basically, because we don't consciously make the decision to breathe.
Yeah, right.
And it gets to a degree of complexity that is
Right.
not conscious
Right.
at that point. Yeah.
So if you really want to get deep and you want to say, well, what's the deepest fundamental stuff of this kind of code theoretic, hierarchical, evolutionary kind of self-actualizing reality? Is it like graph actions? Well, actually, no. No. The deeper fundamental stuff would be this uber state on the emergent hierarchy, which is a consciousness capable of holding within itself the very foundations of the code from which it self-actualized itself. In some sense, they're both, it's the alpha and omega. So you have the omega up here, and you have the alpha down here. Now, a really cool idea is that the alpha is a limit, and the omega is not. And here's my idea on that. If my universe is the positive integers, and I randomly place myself somewhere on that number line, there's a very big difference between the two directions. In one direction, I can reach the integer 1, which is the limit. It's the end of the positive integers. And no matter where I am in the other direction, if I keep going, it seems that I can continue to keep going, right? And then we could talk about the deep philosophy of infinity. But the thing is there's a difference, though, between going one way and the other way on that number line. And so the alpha can be irreducible if you realize that it's hard to imagine any object simpler than the empty set or the dimensionless point, where in the reduction of objects, you really can argue an irreducible object. But in the other direction of complexity, I am telling you that there seems to be no natural logical cutoff in code theory or language theory for the cutoff of complex symbols or complex self-organization. So omega, the force, it may be infinitely reaching towards the infinite. It may be infinitely self-evolving. And still, from our vantage point, be virtually godlike.
There was a certain threshold within Frank Tipler's model, and that is that gravity needs to be under control by life forms. Life forms need to understand gravity,
right?
Especially at a quantum gravity level, I would say.
Yeah.
And at that point, that will allow us to expand beyond the planet,
right?
Beyond galaxies, and unlock this potential to grow beyond the simple organisms.
So he was describing the humans in that, or consciousness animals in that case, of being a negentropic operator, because they understand it, then they strategically exploit it. Yes. Whereas if you don't strategically exploit it, it evolves in a completely different way than if you strategically exploit it. And that's the idea of Heisenberg's notion of negative entropy. So, all right, so the most efficient physical code possible relates to the efficiency proof. And really, my whole presentation was triggered on Fong's last presentation, which was about the efficiency proof. And then I just went into a deep tunnel of thought. And this all comes from that. So thanks for being the catalyst. So the principle of efficient language requires that the universe use the most efficient code possible for expressing reality. The code must, okay, and the principle of efficient language, as I said earlier, is pretty reasonable. It just kind of says, look, if we realize that Noether's second theorem dominates gauge symmetry, I mean, you wouldn't have gauge symmetry physics if it wasn't for Emily Noether or somebody else doing it after her about symmetries in all systems in nature. And so the earlier principle of efficient language is just one special case of Noether's second theorem. And so when you take this and after all, the gauge symmetry experiments that come from our most expensive and largest and most advanced experiments in particle accelerators, that's the best we've got. I mean, the most, best in terms of real data from real experimental machines that are enormously expensive and require amazing, highest level kind of mathematics and physics and engineering. That gives us the standard model of particle physics, which is why you've got guys like Mike Rios, right, and Garrett Lisi running around trying to get people's attention that, that group theory and Lie algebra theory and all of the related things are the best way to attack the problem, in exploring what the proper quantum gravity theory should be. So, and all of that ties back to economy in terms of expression in nature and things like the principle of least action. So I don't lightly choose the principle of efficient language. It just follows naturally by saying, look, it's more logical that nature is code theoretic than random. And it's more logical that space-time is discrete than not, in my opinion. And if that's my choice, that's my axiom, then the natural principle that must follow is that why would nature use some crappy, in terms of efficiency, code? Why? No, nature seems to be trying to do everything she does with efficiency. So we have to start defining why and what efficiency is in a given set of codes, because what we want to do now is start casting out an infinity of codes that nature could have used if she were not interested in efficiency. All right?
Just a comment on that, on efficient language. So building on Garrett's model, which relies on E8, if we look at the E8 lattice as a self-dual unimodular lattice, it's a tightest packing lattice. And these tightest packing lattices have codes associated with them. So it could be tied to those use of, we can look at it as the use of those types of lattices as opposed to other ones that aren't tightest packing.
That's a good way to reduce the infinite.
Yeah, there might be a different way to look at it.
Yeah, I'm with you on that. And then of all the tightest packing objects, which ones are redundant, like the multiples of E8, and so when you get to the one associated with the largest exceptional Lie group as the densest packing of 7 spheres, then you're kind of able to say, hey, maybe it's not that, but boy, this is the best guess that a logical person could throw out. If you're looking for lattices. And
if you're looking at the self-dual unimodular lattices, those occur at multiples of dimension 8.
Yeah.
That are copies of E8.
Right.
So maybe there's more to it.
So the building block of them all is E8, right? So might as well.
There's some efficient coding going on with E8, it seems.
Yep. Thank you. So the code has to be non-local. So we're going to cast out now an infinity. Our first infinity of possible codes that we're going to cast out is the category of non-local codes, because we choose to believe that nature is inherently non-local. We have experimental reasons to choose that. Okay?
But one can still imagine having a local code that expresses a reality that is non-local.
Yes, but yes, totally. But it's more direct to say that nature might express. So I have this idea that nature is geometric. So I'm thinking maybe nature uses a geometric code because it's more direct. And I deal with self-referential symbolism as the special case. So generally with self-referential symbolism, this is like this. So you take geometry and say this geometry in terms of symbolism is like this physical objects on a graph drawing or other ways of looking at geometric physicality. And so similarly, I say that agree that nature seems to be behaving non-locally in a geometric space. And so instead of going indirect and taking a non-local code and trying to imagine clever ways that it becomes a simulation taking a local code and then imagining how it becomes a simulation that's non-local, the first thing you want to try until you find that you can't do it is, well, go direct with self-referential things and use a non-local self-referential code to simulate a non-local geometric reality.
There's just not causality relationship there. That's
Where?
So then you have to remove the word because from that phrase. Because it's not a causal relationship in between.
Well, you can argue that even if you try to produce a local code, but it's really non-local.
How about if I say may? Does that fix it? Okay, so the code may be non-local.
If reality is non-local. Because implies causality, and there's no causal relation between reality being non-local and the choice of your code as non-local.
Oh, that kind of causality? Yeah, that's a broad definition of causality.
Logically, that's not the case yet.
Yeah, for me, I'm just saying that I think reality is non-local, okay? And so I'm looking at how to cast out some infinity of codes and start narrowing down to have a discussion. And so I'm saying that because I think that reality is non-local, I want to play around with exploring first the non-local codes.
Yeah, plus it is not known that you actually can have a local code that describes non-local things. Like I don't think that is, like obvious. And also, even if you have some local code that can describe this non-local phenomena, that code probably is by itself non-local to me.
Well, when you say probably is one thing. When you say because, from the point of view of the logic in that phrase, it means that because reality is non-local, that implies automatically that there's no
she's
other
right.
way.
She's right. So we're going to change this to may.
It has to be non-local.
Right. Yeah. But that does not seems to be like obviously logical to me. It could actually be true. If the reality is non-local, then the code is non-local.
Yeah, but when you say because, it means from the point of view of logic that you have only one option. And that is a direct implication.
Yeah, fair enough. That's fair enough. Yeah. So maybe, I can even go beyond maybe and say probably, right? But it may be possible that Fang's right and somebody very clever with logic and math could make some kind of theorem, right, that argues what she's suspecting. But not important, not so important right now. But because I'm just going to I'm suggesting things. This whole discussion is just suggestions. So this is a suggestion, and I mean probably is the suggestion, okay? So we can define efficiency, and we can explore the universe of all non-local codes that are sufficient for expressing physics as we know it, okay? So we're going to talk about efficiency, and this is called measuring connection density, because I've argued earlier that, again, I have a theme, which is called self-referential symbolism, which is similar to the idea of direct representation, where you directly represent an equilateral triangle directly with an equilateral triangle instead of in English, equilateral triangle. That's non-direct and arbitrary. So with this notion of directness, I want to use a connection formalism, and I want to be quantum, where I apply my quantum philosophy to space and time. So that's going to reduce me to a discretized space that changes over in a discretized manner. And because it's a space, at least this is what I measure it to be, I'm going to believe that space may be a thing, right? As opposed to an illusionary simulation of something underneath it. In other words, the self-referential symbolic philosophy, this directness, is to say that if you wish to simulate space, things in space, geometry, use space, use geometry, use one simplexes, right? So this brings us to the subcategory of graph theory called graph drawing theory, where you practice your graph formalism on a point space. And your connections, therefore, become one simplexes.
The connections do you weight? Does it has weight like a lens?
Yes.
Or how many lenses?
We're going to get into in the definitions. We have a section called symbols. We have dipping our toe into physics, but we're going to get into something that you inspired me on, and it's your idea, and it's that you have a scaling factor of your connections, which is none other than the power series of the golden ratio. And I'm going to explain why that is and how that relates to the probability amplitudes of the of the AB equals P solutions. So the AB plus P solutions between E8 and its subalgebra are really just algebraic expressions of cut and projection operators. And a cut plus projection operator can select on-off connections and points in your possibility space at any power of the system. So in our system of the QSN, the power series is the integers on the golden ratio, right? It's the golden ratio power series. So in other words, each AB equals P operator algebraically has a rank, which is called the inflation-deflation rank. So yes, length is important. So C, so these are terms here. So C would be the average connection rank, or number of connections in a space, which is measured by the weighted average of all vertex types divided by 2, and then using a metric, which is based on the average near neighbor distance of the vertices. So if we have the cubic lattice, we have an average vertex rank of 6, and we have a near neighbor distance of 1. V is the exponent of the average near neighbor distance length, serving as the spatial metric used to measure connection density that I just said in the other slide. For example, let us say the average near neighbor metric is 1. And we have a small two-dimensional subspace that we wish to measure the connection density for. Now our exponent for this unit metric, in the case of this example, is 2, right? So it's whatever your value is, it's the square of that, right? So dealing with the...
Can you explain again?
Okay, so let's say, well, actually, let's say that our metric is 2. Okay.
Okay. The metric is 2.
Means right. A near neighbor distance.
Okay.
And so we're dealing though with this the tiling on the Z2 lattice, the checkerboard, and we have an average valence rank of 4.
Yeah.
And our exponent on the metric 2 is the square of 2. So our V value, which is the exponent of our unit metric, is 2. Let me tell you where I'm trying to go, and you can help me to get there. The density relates to the dimension. And so if you have...
So you put the dimension number as an exponent, or no?
Yes, so the dimension number is the exponent of your unit metric.
Okay, so 4 to the 2 then?
So if our unit metric is 2,
yeah,
then it doesn't matter what this number is here. Okay, but if our dimension is 2, then V equals 2. I'm gonna on the next slide I'm gonna combine C. Okay, I've defined C, and now I'm defining V as the exponent. Okay. Okay, and D is the third thing, and then here's the equation. So D is the connection density, which is calculated, is C over V equals D.
Connection density divided by dimension.
Yes. So let me give an example. If I have the plane and I have some average vertex density of 3, let me just, I actually have it on the slide. For example.
Divide, I think it should be like a square, like a
the math works.
Roots.
The math works. Let me show you, and then you tell me if it's correct. For example, if we have a metric of 1 in R3, then we have V equals 3.
Okay.
And if our C value is 3, we have C over V equals 1. That's our D. So remember, C over V, so D here is 1. Okay? If we are measuring an R2-based system with a unit metric 1 and the same value C, we have C over V equals 3 over 2 for a denser connection network with a D value of 1.5. In other words, you get penalized with your average vertex density, you get penalized with higher dimension given the same unit metric. So I can go over this again. So you see here, and it's very logical, right? So there's a lot more space, really, in a cube than there is in a square, in some sense, right? So you have a higher dimension. So I can't just say, oh, I want to find out what the highest average vertex is to measure the connection density of my graph drawing formalism. I must penalize myself or consider the space, right? Because if I have an average vertex density, let me give an extreme example. Let's say I have an average vertex density of 3, and I have this in a 100-dimensional space. And then I achieve another network that I can put in a graph drawing space in 3D, and it has an average vertex density of 3. So common sense, without even thinking about this formalization, you can presume, well, gosh, probably your graph drawing in 100 dimensions that only gives you an average connection density of 3, or average vertex rank of 3, is probably somehow not as efficient as if you had the same average vertex or connection power in your network in a 3-dimensional space.
Yeah, that makes sense, because if you consider the Z lattices, Z2, Z3, Z4, Z5, right? So if you consider them as the equal density,
yeah,
right? And then their ratios are the dimension ratios.
There you go. Okay, so everybody okay with this? If not, I can go back to the slides and do it again.
Just it's good to check that with the Z theory, we get the properties that Fang just explained.
But do you agree that I've established it in this case? Do you want me to go over this again?
Because
we understand. You don't give a lot of examples.
What?
You don't give several examples.
No, I gave.
So I would like to have the example given by Fang, more studied.
Okay.
For dimension 2 and 3 and 4, and that's
fair
all.
enough.
After that, we can really understand the formulas.
Good. Okay, so I leave it with you guys to make this to later check this, because I want this to be a core rigorous definition that quantum gravity, our program, uses, and if it gets through you, then we can use it as a really simple, easy to explain way to define the efficiency of a given graph drawing, where you cannot just use the connection power. You have to also...
Sure, you have to use the dimension
to...
The subspace dimension.
Go back to the V definition. I just want to...
Sure. So V is just the exponent of the average near neighbor distance length, which serves as that near neighbor distance length is what serves as your metric that you're going to use to measure connection density.
Maybe
and so
calling it exponent may not be so.
Oh, I didn't need to. All right, I didn't even need to say exponent. I could have just said.
It's
I should have just
dim
said,
subspace.
Yeah, I should have just said
dim
dimension.
Yeah.
So that's true. So, okay. So.
It's average valence divided by dimension. So the formula.
That's right. That's right. Because. Yeah, so we pay a density price, right? We're talking about connection density, because what you're worried about in graph theory, or what you're worried about in neural network theory really is artificial neural network theory. You're just worried about, for your conserved quantity, which is your connection actions, or your vertex on-off actions. You have these conserved quantities, and you want to get the most complex encoding power, which is what neural networks do. They're creating patterns of connections. So you want to, you want to do that in the most economical way possible.
So I believe that something is missing is to take also into account the number of lengths that we use in the network.
You talk about the
lengths. I will talk about that. So we pay a density price for higher dimensionality, all else being equal, okay, when it comes to measuring the connection density of a neural network. Pretty simple stuff. Not only is there a higher symbolic load computationally with an otherwise equal higher dimensional network, there is a simple, very logical density difference. When I mean higher symbolic load, I mean imagine a 1 million dimensional lattice and trying to deal with that algebra or a neural network. You try to deal with a 1 million dimensional neural network either algebraically or as a spin network. It's just going to be common sense, more bulky computationally than an otherwise powerful connection network for the same number of actions in a lower dimensional graph drawing or neural network. Because you have to consider the system that you're computing in or that the universe computes in. You can't just ignore that, because that costs you money, right? That costs you something. So, right, either algebraically or spatially, it's costing you. So, and the density of a space of geometric solutions defines the spatial density of the information that that space can hold, right? So we have some space and we have some quantity of geometric solutions, graph drawing solutions in that space or spin network. And so we might think, well, nature just wants, in a sense, to use as simple a space as possible that she can get away with the most connection density in the neural network possible. So that's the thinking behind this. So information in a graph drawing self-referential network as a neural network is simply just pattern. It's just coherent pattern at any scale in the emergent hierarchy of patterns, ranging from primitive graph theoretic actions such as a connection to a pattern in ordered sets of such connections, all the way to abstract emergent information such as the code in DNA, on up through even more ultra-abstract information in the form of the idea of a song. Because you cannot have an idea of a song without some participation from the graph, right? Some participation of the peptides, the atoms, right? The subatomic particles, the quantum gravity structure, right? Nothing that you can possibly imagine in this universe as an abstract thought seems to be completely separable from the foundational structure, whatever you think that foundational structure is. And because saying otherwise is to be a separatist. So a holistic cosmology is something which recognizes the simple logical idea that everything is connected, where you don't have the idea of a God from outside the universe that was never part of the universe and then he just created the universe. Like, you don't have separation. You go back to the original word of universe, which means all that is, right? And you get away from these other ideas like multiverse, these invented terms, right? I mean, I don't have a problem with multiverse as an idea, but then it destroys the original meaning of what universe means as all that is, right? All that exists. So no information, regardless of how high it is up on the emergent hierarchy and how non-physical or abstract it appears to you to be, can exist without influencing all strata in the hierarchy above and below it. It's all connected. Non-local, it's non-locally connected over space and time. So for example, you can't think of the idea right now, if you wanted to, of the word love. None of you can just think of love or experience the emotion associated with love in your body without trillions of dipole orientations coherently changing in your brain and throughout your body, along with all sorts of chemical changes, proton a photon and electron flows that result from that experience of love, global brainwave signatures in the EM spectrum in your brain, topological patterns in your brain, all defining that physical, abstract, emergent pattern of the thought and the emotion related to your feeling of love, right? That thought. So you can't just create two regimes of abstract, non-physical stuff and then physical stuff. It has to be connected. So if you could theoretically be a consciousness made of bosons and think, boson consciousnesses, if there could be such a thing, would exist across time, right? They would have a trans-temporal experience. Even that kind of consciousness could not think of love. If you were that, you would still, you would not be able in a logical way to disconnect yourself from the rest of reality with that emergent abstract thought, from the simplest strata on up through all strata non-locally throughout all of space-time, unless quantum mechanics is untrue, or if that doesn't do the trick, unless our program is untrue. So this notion of emergent information and strata connectivity, the connectivity between strata, is the core principle of emergence theory and of complex systems theory in general, where ultra-complex things are causally connected to irreducibly simple things, always acting back upon the simple strata and the strata above it. And in a quantum non-local version of this, the action goes both directions. The influence has to go in time, I meant to say. Has to go both directions of time and both directions on the emergent hierarchy. Quantum gravity.
Is that the same thing?
No, because
with time you do create a hierarchy strata, right? That's the one thing linear in time or in order or whatever.
They're related in that way, but they're not the same thing because.
So if you go higher in hierarchy, you also go further in time. Of course, in between the strata, you have this kind of like back reaction thing.
Yeah, that's true, and I like that. But you can go back 1 million years ago and find a complex system. And then you can go today, 1 million years later, and find a simpler system. And then the two systems are connected non-locally across what you can call time. And so it's helpful to have two different words for the two things, even though it's true what you're saying about how things evolve. But yeah, we have very simple things here today, even 14 billion years after the kickoff of
but
this.
in the bigger picture, those simpler things may be part of a higher organizational hierarchy.
Right, and they are, because if you go back to
they're simpler locally, but there may be small, simple pieces in the...
Exactly. So that's, I'm going to get into that. So so if you caught what Cynthiana is saying, so go back to 5 Planck moments after the Big Bang. And you won't find very many things there locally that are very high up this emergent hierarchy. But take one. Take some system there that's some E, something greater than little I, 5 seconds after the Big Bang. Because from our first principles of quasi-crystal math, the empires, which are instant, they don't propagate. Empire waves propagate, but the empires themselves run through time, right? They run their...
I think the best example is our human body. It's a strata, whatever, and then the little little small systems are the lower strata. So our body, if I have some emotion of something, does affect the lower strata.
But she's talking about the time, though. So
that's the time. That is the time. Like the bigger the emergent information. Well, I guess when I have an emotion or something, that's a higher level information, and that actually changes the lower system. Then that's I guess like after. In time, it's not like before and after.
Yeah, no, I like your analogy because you are at the end of a evolutional series, basically. So you start with small organism and you get to the human body. And of course, in your human body, and it's exactly like what you were saying with the universe, you have a small organ that's simpler than some very simple organism. But that's
Cynthia,
part of the...
let me just say, Cynthia, so look at it like this. So we have the hierarchy of complexity here, then we have the shells of time. They're different regimes, and they're connected. But I want to finish with the example, then we'll go to lunch, which is, I said 5 moments after the Big Bang, you find some very simple, complex system. Maybe it's at strata 3. It's very, very simple. And then around those frames, locally, like around frame Planck moment 4 and 5 and 6 and 2, right around there are other things that you can view as in space, non-locally, to that system that would be connected spatially, non-locally. But then that system, 14 billion years later, which is a hell of a lot of Planck moments, or shells if it's shells, that is actually part of another complex system, because the empires run through all those shells, of some little complex system in your body.
That's exactly.
So it's kind of like you have both ideas. Oh, yeah, so I'm with you, but you have kind of both of the things. The shells, where the universe tends to get greater and greater strata count as this goes up, and then you have the strata count itself. Probably a better way to...
It's not complementary, it's not perpendicular.
Yeah, I think that's a bad way to draw it. So this is I'm just going to stop here because I have no idea how many more slides there are actually. Could be just 3, in which case I should keep going. I don't know. But I'm going to stop here, and then we'll reconvene at 1:30